Hi, in this video, I will be showing you problem number 15 of chapter 11 section 2. Let a sub n, or the nth term of the sequence, equal to 9n over 8n plus 1. Part A, determine whether the sequence is convergent. Part B, determine whether the series sigma an, n varying from 1 through infinity, is convergent. If the limit of the nth term a sub n equal to L, where L is a finite number, then the sequence is convergent. This is what we saw in one of the earlier problems as well. So in order to determine whether the sequence is convergent, which is the first part of the problem, we'll find out the limit of the nth term. Limit as n approaching infinity of an is limit n approaches infinity of 9n over 8n plus 1. Anytime you do n approaching infinity of a ratio, then we always apply the rule that divide the numerator and the denominator by the highest exponent of the denominator. So either we are going to divide the numerator and the denominator by n or 8n, both are okay. So limit n approaches infinity, 9n divided by 8n divided by 8n plus 1 divided by 8n. Thus we get limit n approaching infinity, 9n over 8n divided by 8n over 8n plus 1 over 8n. So we are going to divide each one of the terms below. It's a binomial, so we are going to divide by 8n each one of the terms in the binomial. So the numerator, in the numerator n cancels out. So we get 9 over 8 divided by 8n over 8n, which is a 1, then 1 over 8n, which will approach 0 as n approaching infinity, or dividing 1 by a very large number. So the whole thing is 9 over 8 divided by 1 plus 0, or 9 over 8, which is a finite number. Therefore, the sequence an is convergent. That's part A. For part B, we have to determine whether the series is convergent or divergent. So if we eliminate the test for divergence, then we can apply some other technique like partial sum or something to see whether it is convergent or divergent. The easiest test for any series is the test for divergence. So we will find out whether test for divergence tells anything about the series. So test for divergence says if the limit of the nth term an as n approaching infinity does not exist, or if limit of the nth term is not equal to 0, then the series sigma an is divergent. But in part A, we already determined limit as n approaching infinity of an, which is limit as n approaching infinity of 9n over 8n plus 1, which we found out in the earlier case, part A, which turned out to be 9 over 8. Here we have to say it's not equal to 0. Because it's not equal to 0, then the series sigma an, n varying from 1 through infinity, diverges by test for divergence. Keep in mind always when you do these kinds of problems, you're going to be seeing a lot more tests to decide whether a series converges or diverges, and you have to always state the series diverges or converges by what test, by applying what test you are able to conclude your result. Hope this video helps.